I'm Patrick Madden with the Computer Science Department at Binghamton University. In this video, I'll give a short overview of our paper, Still Benchmarking After All These Years. My co-authors Ismail Bustany, Jinwook Jung, Nat Viswanathan, and Stephen Yang also have video segments. The impetus of the work is an ISPD paper I wrote back in 2001, 20 years ago. The program chairs thought it would be interesting to take a look back on benchmarking in physical design and to document some of what has happened and how things have evolved. To start with, though, let's go back another 10 years to 1991 and a DAC paper by Chris Kosminski. While not the earliest days of VLSI physical design, many ideas and methodologies were still quite new, and there's lots of uncharted territory. There were few circuits of any size available to the public, and much of the technology used to create chips was kept as a proprietary secret. The MCNC benchmarks shown here was the best that academia had access to. They were relatively small, even for the era, with circuits having only 10 or 20,000 cells at most, but they were highly influential. Kosminski's comments at the end of his paper, though, foreshadowed the trouble ahead. He noted that future benchmarks would need to come from groups willing to release their designs to the general public, and this was not done very often. As a result, 10 years later in 2001, the MCNC benchmark set was still in wide use, with only a few new designs being added. The gap between industry practice and academia had gotten progressively wider. Much of the literature was hard to interpret simply because design styles changed and metrics changed too. Putting published results into one big table really highlighted the problem. Some results used wire length assuming channel routing, while others were used over the cell. Pad positions and a number of rows varied, and there was even variation in something as simple as half perimeter wire length. The 2001 paper amplified what almost everyone working in physical design already knew. New benchmarks were needed, and they were needed badly, both to develop new algorithms and also to train new EDA professionals. There was some good news, though. A number of things happened, making things much better and changing how benchmarking was done in physical design. I'll briefly mention a few of the big events. First off, in 1998, Chuck Alpert, who was at IBM at the time, was able to get a number of circuit netlists released for partitioning. He stripped off cell names and functionality, and did a few other things to get approval for the release of a large benchmark set. While this was initially intended for partitioning research, the community quickly adapted them for placement. In 2000, Professor Majid Sarfzadeh's group attached standard cells to the partition graph nodes, creating a new batch of placement benchmarks that more closely resembled industry practice. Then, a few years later, Professor Igor Markov's group took the netlists and created mixed-size placement benchmarks. In both of these cases, the original intellectual property from IBM remained safe, while also enabling the academic community to engage in some really interesting work. I should note that throughout this era, Professor Andrew Kang's GSRC project, and in particular the GSRC bookshelf file formats, were tremendously helpful. Most industrial designs use left-def format, which is complex and difficult to parse. The bookshelf formats, by contrast, are simple and easy to use, making it much easier for new students to jump in and begin work. Along with the new benchmarks, there was an explosion of research and placement, and in particular for mixed-size design. This flurry of activity built into a hurricane force with the introduction of the ISPD contest series. Each year since 2005, the symposium organizers have worked with industry colleagues to hold a competition. This brings in new benchmarks, improved comparison metrics, and sometimes entirely new types of problems to consider. These contests have been a fantastic collaborative effort between industry and academia, and many of the people working in EDA today have participated. To briefly note, the first contest in 2005 introduced a new set of placement benchmarks with up to 2 million cells, far larger than anything that had been available to the public earlier. There were standard cells, macro blocks, and lots of white space, all reshaping how academia pursued the problem. To sum up my section, physical design benchmarking had something of a rocky start. Nearly everything in modern electronics is unprecedented, and the field had been evolving at a breakneck pace. Thanks to the collaboration of many, many people, we now have a robust and reliable system. My other colleagues will cover some of the details of the other contests and also the really great work that's happening now in open source tools. There are a lot more details in the paper, and I thank you for your time.